Hi guys, so today we're going to be doing recursion and special sequences. Before we get started with example 1, let's look at some of our vocabulary. So the first one here is the Fibonacci sequence. This is a sequence that is often found in nature. Okay, and the Fibonacci sequence starts with 1 and then 1 again, 2, 3, 5, 8, and so on and so forth. And how the Fibonacci sequence is formed is that it is the sum of the previous two terms. Right? So the first one starts with 1, the second one is 1 again because it's 1 plus nothing. Okay? Then the next term is the previous two terms, so 1 plus 1, and so that becomes 2. And then the next term is the previous two terms added together, so 1 plus 2 is 3. And then the next term after that, 2 plus 3, and that's why it's 5, and then after that it's the 3 plus 5, and that's 8. Okay? And so how we write the formula for the Fibonacci sequence is a sub n, any term, equals a sub n minus 2 plus a sub n minus 1. Okay? And so a sub n minus 1 is the previous term than the one we're talking about. Right? So for example, if this is a sub 4 minus 1 is a sub 3, which is the previous term. Okay? And then a sub n minus 2 is the term before the previous term. Right? It's 2 away. So this is an example of a recursive formula, and a recursive formula means that each term here is formulated from one or more previous terms. Okay? So previously when we talked about geometric sequences and arithmetic sequences, the formula we gave for those are known as explicit formulas because we can find any term based off of where it is in the sequence, right? So we don't need to know the previous ones. Like for instance, we don't need to find the 10th term. In order to find the 10th term of an arithmetic sequence, I don't need to know what number 9 was, I don't need to know what number 8 was, I don't need to know what number 7 was. As long as I know the first term and the 10th, and that it's in the 10th place, then I could find what that term equals. Whereas in a recursive formula, if I wanted to find the 10th term, I would have to know what the 9th one is, and then in order to know what the 9th one is, I would probably need to know what the 8th one is. In order to know what the 8th one is, I would need to know the 7th one, and so on and so forth, right? And so the recursive formula is useful sometimes because there's no other way to write an explicit formula for it. However, the drawback behind that is you need to know the previous terms. Okay. So here, starting with example 1, we're given a recursive formula. It asks us to find the first 5 terms of the sequence in which a sub 1 equals 4, okay? And then a sub n plus 1 equals 3 times a sub n minus 2. Okay? And then it starts with terms start at 1. Okay? So here what this means is that a sub n plus 1 means that the next term, okay? So the next term is 3 times the current term minus 2. Okay. So here, if we're talking about the first 5 terms of the sequence, a sub 1 here is the first term. Okay. So that's really important. For a recursive formula, you have to give a term to start with. Right? So in this case, it gives us the first term, so 4. Okay. Then to find the next one, it's going to be 3 times 4, which is 12, minus 2. And so that gives us 10. Okay. Then to find the next one, we're going to do 3 times this one, 3 times 10, 30, minus 2, which is 28. Okay. Then to find the next term, we're going to do 3 times 28, which is 84, and then minus 2, and that'll be 88. Then to get the one after, so we'll say 3 times 28 is 84, minus 2, so that's 82. Okay. Then to get the next term, we're going to do 3 times 82, and then minus 2, and that will give us 244. And there you go. Right. So you can see them doing that for each one. Okay, they're plugging in the previous one, multiplying, and then minusing 2. Then they're taking 3 times the previous one, minus 2. And so on, so on. Okay, so why don't you try CYP1 here on your own, and then once you're done, come check your answer. Okay, you should have gotten -1, 2, 8, 20, and 44. If you got that right, you can move on to the next example. If not, here is your explanation. Okay. So we want to find the first 5 terms. It gives us a sub 1, our first term already, we know is -1. Right? Then it gives us this recursive formula, and what we know is in order to find the next term, we're going to do 2 times the current term and then plus 4. Okay? So here, it's going to be -1 times 2, that's -2. -2 plus 4 gives us 2. Okay? Then, to do the next one, I'm going to do 2 times 2, which is 4, plus 4 gives me 8. Okay. Then I'm going to do 8 next. 2 times 8 is 16, plus 4 gives me 20. I'm plugging in. 2 times 20 is 40, plus 4 is 44. There we go. Okay, with example 2, we're now going to find and use a recursive formula. So a pharmaceutical company is experimenting with a new drug. An experiment begins with 1.0 times 10 to the 9th amount of bacteria. Okay? A dose of the drug that is administered every 4 hours can kill 4.0 times 10 to the 8th bacteria. Between doses of the drug, the number of bacteria increases by 50%. We want to write a recursive formula for the number of bacteria alive before each application of drugs. Okay. So what we're going to do is we're going to set B sub n is going to be the number of bacteria that is alive just before the next dose. So just before the nth dose. Okay. Then, since we know that 4.0 times 10 to the 8th of these will be killed by the drugs, whatever it is, the previous one, okay, we take whatever is alive then, we're going to subtract, because it's then going to kill, 4.0 times 10 to the 8th, right? So if it's killing some off, we're going to subtract those that have been killed off. Okay? And then we're increasing by 50%. Okay? So then times 1 is 100%, right? And so if we're increasing, it'll be 100% plus 50%, so that will be 1.5. Okay. So then B sub n plus 1 is going to be 1.5 B sub n minus 4.0 times 10 to the 8th. Okay. And then if you want, you can distribute it and simplify. Okay. And then what we know, when you give a recursive formula, you should always say what we're starting with. So here, in the beginning, there is 1.0 times 10 to the 9th. Okay. So now we're going to find the number of bacteria alive before the 5th application. Okay. So here we know that in the beginning it's going to be 1.0 times 10 to the 9th. Okay. So after the first application, probably better to say 0. So 1 cent for the first dose. So before the first dose, there was this amount. Okay. So then before the second dose, then it will be 1.5. And then it will be 1.0 times 10 to the 9th minus 4.0 times 10 to the 8th. Okay. And then that gives us 9.0 times 10 to the 8th. Okay. we did this, entered it into our calculator, 1.0 times 10 to the 9th minus 4.0 times 10 to the 8th, and then multiplied it by 1.5. Okay. Right. So note how I took the previous term and plugged it in. Okay, so right before the second dose, this is how many there are. Okay. So right before the third dose, I'm going to do 1.5, and then now it's going to be 9.0 times 10 to the 8th minus 4.0 times 10 to the 8th. Okay. Enter that into my calculator, and that gives me 7.5 times 10 to the 8th. Okay. Then I'm going to do right before the fourth dose, so 1.5, I'm going to take the previous one, 7.5 times 10 to the 8th minus 4.0 times 10 to the 8th. Okay. And then right before the fourth dose, there is 5.25 times 10 to the 8th amount of bacteria. Okay. And then now, right before the fifth application, so B sub 5 equals 1.5 times 5.25 times 10 to the 8th minus 4.0 times 10 to the 8th. Okay. And so right before the fifth application, there is 1.875 times 10 to the 8th bacteria. That is it. And so what you can notice is that we take the previous term and we substitute it in. Right? Took the previous term and substituted it in. Took the previous term and substituted it in. Took the previous term and substituted it in. That's what makes it recursive, right? It's based off of what happened before. To get the next one, I need what happened before. Okay, okay, so why don't you try CYP2, and then once you're done, enter the answer. Okay, so for your recursive formula, you should have gotten B sub n plus 1 equals 1.5 times the quantity of B sub n minus 6.0 times 10 to the 8th. If you chose to distribute it, this is how it simplifies. 1.5 times negative 6.0 times 10 to the 8th is negative 9 times 10 to the 8th. And then again, you have to state what your first term is. The reason why is, for example, if I had a sequence like 3, 5, 7, 9, 11, the formula for this is any term is the previous term plus 2, right? However, I can also have a sequence like 6, 8, 10, 12, 14, also the same pattern where each one is the previous one plus 2. However, how do I know if I want this one or another pattern that adds 2? And that's why it's important to state what the first term is. So that way we know where it starts. Okay, so make sure you have this. So this one talks about, next term and then like previous term, right? Another way you can also do it is you can do B sub n, and then you can do this as B sub n minus 1 as well. That works. Okay. So here it's because this again represents right before the dose. Okay, so it's however many bacteria there was before, minus, because we're killing off 6.0 times 10 to the 8th, and then it increases by 50%, so that's why it's 1.5 times that. Okay. So B asks for how many of the stronger doses of the drug will kill all the bacteria, and that's in 2 doses. Okay. Right before we do our first dose, there is 1.0 times 10 to the 9th. Okay. Okay. Right before the second dose, so one has already happened, we killed off a bunch. Okay, multiplied by 1.5, and we got 6.0 times 10 to the 8th. So this is right before the second dose. Okay, after the second dose, this is before the third dose. What happens is 6 times 10 to the 8th minus 6 times 10 to the 8th is 0. So there's already no more bacteria left after that second dose, right? Because this is before the third, which means only the second dose was given. There you go. Okay, so our next example is with iteration. So an iteration is the process of composing a function within itself repeatedly. So for example, if you compose a function with itself once, the result is f of x, right? We took f of x and plugged it in again. If you compose a function with itself 2 times, the result is f of x, right? Or it's written like this. So we can use iteration to recursively generate a sequence, right? You're plugging it into the previous one, getting the next one. Okay? So it starts with an initial value of x sub 0. Okay? So here we want to find the first 3 iterates, x sub 1, x sub 2, x sub 3 of the function f of x equals 2x plus 3. The initial value x sub 0 equals 1. Okay? So here we're going to plug in f of 1, right? So that's the initial value, equals 2 times 1 plus 3. 2 times 1 is 2, plus 3 is 5. So this is the first iterate. Okay? The second iterate will now use f of 5. So it'll be 2 times 5 plus 3. 2 times 5 is 10. 10 plus 3 is 13. So this is the second iterate. Okay. Then the third iterate is going to use 13, which came before. So 2 times 13 plus 3. 2 times 13 is 26. 26 plus 3 is 29. So this is x sub 1, x sub 2, and this is x sub 3. Okay. So why don't you try CYP3 on your own, and then once you're done, come check your answer. Okay, you should have gotten 2, -1, 2, -1. Okay. If you got that right, you can get started on your homework. If not, here is your explanation. Okay. So it asks us to find the first 4 iterates. We know that f of x equals x squared minus 2x minus 1, and the initial value x of 0 equals -1. Okay? So we're going to plug in -1 to get the first iterate. So -1 squared is 1. -2 times -1 is 2. So 1 plus 2 is 3. 3 minus 1 is 2. Okay, so that's my first iterate. Okay? Then to get the second one, I'm going to take this 2 and plug it into the function. So 2 squared is 4. -2 times 2 is -4, so 4 minus 4 is 0, 0 minus 1 is -1. Then it takes us back to this basically, and that gives us 2, and then takes us back to the 2 again, gives us -1. So third iterate and the fourth iterate. And so 5th, 6th, 7th, 8th, it's just going to keep going to -1, to -1. And how we get it is we take the previous one and plug it into the function to get the next one. Okay. That's it for today. Have a great rest of the day. Bye guys.